Oops, I started the stream before sharing my link somewhere. I should not have done this. But yeah, I haven't given lead code contest so far. I should have. Maybe I should have given today. I have prize too. So do we have viewers? Hi guys. I start stream a bit early. Wait a minute. I want to not use this earphone. I don't want to use earphones. I don't want to use earphones. Let me close them. Hello. 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 Hey, can you guys hear me? Can you guys hear me? Damn. Okay, but then this doesn't show that you can hear me. So, see, I have solved this problem today. I opened few greater than or equals to 3000s. I tried this difficult one once again, but then that I was not able to solve, and then I moved to this one. I was able to get the solution to that, but then I was able to get the solution to that, but then my solution is n root n. My solution is n root n using two things. For d less than root n, I do something. For other cases, I do something, but it's giving clearly. So for my lead code viewers, I know you get scared of this interface. I know you get scared of code forces problems. But good news is I'm trying lead code contest today. See, let me close this. Let me close this. Did you guys see that? I Googled this thing and then I copy pasted that. So we have viewers, right? Hello. Guys, let me know if a sound is gone or why zero likes? You guys should like that. Okay. See, Hitachi stolen first like. So so won't you kiss me on the mouth and love me like a sailor when you get it itched? What is this? No, I have an account. I have an account, I think. 1 minute, guys. Wait, I think I remember I have an account. I'm sorry for this, but wait a minute. That's not working. Let me make a new account then. What should I name? I think I made an account with my. Huh? 1 minute, guys. We're going to do this. I'll do it on phone. 1 minute. I'm changing my password on my phone because I cannot show you my personal information on my emails, right? New password again. I'll just name it some anime girl. So password has been changed. I'll try to save it too. What the fuck? See, guys, finally we were able to open LeetCode. I've solved 8 problems so far. Median of sorted arrays, 7 submissions. See, beginner. How a beginner submits. 2021 and then 2024 accepted on first attempt. That's how you grow. That's how you grow with time. See, I'm just joking. So now we are at here. Bi-weekly contest, weekly contest. So guys, we are doing guys, focus on the contest. Let's see how do we do it. We have to make it most productive to the viewers, right? We have to make it useful to the viewers. Streams, studying set. I'll open that folder. So yeah, so let's see if our competitive programming CPH editor will work on the bi-weekly contest. Should I give it virtual? Let me give it virtual. So contest is running 1 hour 30 minutes, just 1 hour 30 minutes. They should give 5 hour contest. And what is this in between? School time, lead time, 119 fucking dollars per year. What is this? Bring lead code to your school. You guys can bring me to your school if you are giving me. If your school gives me $100 isn't much. Sorry. Okay, $100 is a lot. No, $100 isn't much. Is it per school or per person? 50 or more schoolmates. Damn, it is 50 times 120 per year. Times 90 rupees, right? $1. 5 lakh per year. Oops, it's my resume, I guess. You guys may think why my resume is here. Because I'm trying to shift, maybe. I don't know. I should not say such things on live streams, but fine. No one sees my long videos, right? So we are here. Time is already running. You guys should read the problem because time is running. So where are problems? Where the fuck are problems? Okay, here we have problems. Okay, where is second problem? I can see Q1, but where is second problem? Ah, we cannot see all the problems so easily here. So we have Q1, Q2, Q3, Q4. Okay, greater than 5 is not possible, that means. Okay, so now let's read the first one. Okay, smallest absent positive integer greater than average. Smallest absent positive greater than average. I think I have read this problem and I was just joking. Okay, leave that. You're given an array. We want the smallest absent positive integer such that it's average of all elements in array. The average of the elements is defined as the sum of all its elements. So we have a value, okay? We have one particular value which is average, let's say, and then we want something that is not in this. It doesn't seem that difficult, right? Because we have n distinct values, and then we have some line. We have to see after this what wherever there is a hole. First integer there is a hole, right? So I don't think this is that difficult. So values can be, oh, values are also small. Values are also small. If values are from 100 to minus 100, we can just brute force this, right? We can say average is less than or equals to average less than or equals to max less than or equals to 100. So I will brute force all to find. I will check till 101 because 101 is not there, right? I will check from 0 to 1 to 101. I will check from 1 to 101 to see if that is present or not. Okay, int present 101 equals to 0, let's say 102 equals to 0, let's say. So we also should find average. So to find average, I'll just find sum, and we know total number of things as n, right? I don't know why we have class solution. We can just take input and everything, right? Why do they do this? Is it because tests do this? Is it because company tests do this? Or company tests do this because shitty lead code does this? I don't know. Some I'm finding some guys. See, or we can even do this thing to find some. So now we have some. Now we have n. I'm not. I will use sum by n to find average. Okay. In now I will go over all positive integers till 101. Okay. If I will also make present of I equals to 1, means I is present. If now what should we do? If present of I equals to 0, and because in the worst case 101 will not be present, right? And 101 is definitely greater than average. Answer less than or equals to 101 because 101 is definitely an answer, right? So that's the main thing we are using, like answer less than or equals to the biggest element, or answer less than or equals to 101. even even if the values are very big, even then answer less than or equals to n, we can say. Why? Because there will be a hole, right? Like if n things are there, there would be a hole. That's what we use in mex also, minimum excluded or something. But then now we have average, which is nums of. So if I times n greater than, not even greater than or equals to, greater than sum. So now we have to be careful. I is within 100, n is within 100, so that multiplication will not exceed integer. So it's fine. Return I. And we know this will definitely happen, so we need not return anything later. So if we run this test case, struggling with interface. So don't judge now. Okay, this guy got This guy got a wrong answer on first question, and some other stream got accepted. Okay, I know you guys go make such conclusions very easily. Like how you make conclusions on yourself, like CF is difficult, I cannot solve this difficult problem. So when I'm doing present, I only care about positive integers, okay? So it's passing. See, we are working against time, guys. Time is running down. 7 minutes have passed. How difficult was the first question? Some guy might have spent the whole contest and might not have seen these constraints. Some guy might have googled, okay, how to find minimum average greater than so at least someone might have googled, right? Someone might have googled smallest to integer and then they will write it down maybe, okay, smallest on their notes, smallest option positive greater than average, this is the solution, I'll remember it for the next contest. We have all those types of guys that does hard work when they don't have to. So how many points did we gain, by the way? 3 points, because it's an easy one. So now here we are. Venus gets scared of scene and all that. That's why. Okay. That's why they didn't give scene here. Okay, I got it. Someone might have, bro. You don't know. Like, probability, right? It is like so people are weird. People do everything. You're given to integers w and n and an integer array. So with this itself, people will get scared because there is a big statement, right? You're given integers w and m, two integers, and an integer arrivals where arrivals of I is the type of item arriving on day I. So on day I, this type of item will arrive. It seems days are one indexed because it's shitty code. I mean, sorry. Code forces are also mostly one index. But then why are they mentioning they are one index in bold? Okay, let's leave that. Sorry. Code force is also mostly it's one index, but it's fine. I mean, I didn't like it. Why are they mentioning? See, this is bad. Why are they not saying like clearly from 1 to n you have an array called arrivals of n, where arrivals of, so n, see, arrivals has been defined but arrival size is not defined yet. Okay, so arrival size hasn't been told before telling this. Code forces problem statements are much better, I think, right? So what is arrival size? Probably, okay, what is arrival size? Because it's a vector, we don't care. And then here we may have that, we may have here arrivals dot length less than or equals to 10 power 5. I don't know how they make their problem statements, but okay, let's read the problem. Items are managed according to the following rules. Each arrival may be kept or discarded. So we have arrivals arriving on days, okay? We don't know what these two shit things are or so far, but then they have a type and they keep coming day after day. Each arrival may be kept or discarded, it seems. Okay, an item may only be discarded on its arrival day. We can only discard it once it comes, it seems. Okay, for each day I consider the window of days max of 1 comma I minus w plus 1 comma I, which is nothing but w most recent days, it seems. On day I, we will look at like last w days. Okay, for any such window, each item type may appear at most m times among kept arrivals whose arrival day lies in that window. So whatever the window you have previous days, each different types can only occur at max m times. You cannot have some type m plus 1 times, it seems. Okay, that's the restriction you have for number of times. Okay, if keeping the arrival day I would cause this type to appear more than m items in the window, that arrival must be discarded. So we have this window, and if in this window, if you keep this thing, among kept arrivals, not just all arrivals, among kept arrivals, this should happen, it seems. And then if keeping the arrival day I would cause its type to appear more than m times in the window, the arrival must be discarded. Written minimum number of arrivals to be discarded so that every W day window contains at most m occurrences of each type. So we have many W windows, right? We have many W windows. So is this a process that we have to do? So it's a process we have to do. They are not asking us any question. They're just trying asking us to brute force this process. Brute force means to just simulate this process and then find the, and then what is minimum number of arrivals to be discarded again. So this problem is confusing me. I'll go to problem 3. Okay. Why is it not hard? 4 is hard. Let me read 4 too. Maximum XOR of subsequences, because you guys might have kept 4 2 after an year or something, right? You guys might have thought, okay, I can only solve q1 comma q2. I cannot solve q3 q4. Those are like, maybe I have to do some other course. Maybe I have to buy some other videos, and then I have to come back to 4. You guys might have thought, right? So let's just see what is there in the force. Sorry, in the 4. Let's just see like how difficult XOR is. Maybe you have to learn some XOR videos or not, or can we solve everything from the problem itself? Let's see that. You're given an integer array nums of length n, where each element is a non-negative integer. Select two subsequences of nums. Subsequence means just subset, because if you know maths, subset is subset of indices is a subsequence, I guess. But it also has an order. Subsequence also has an order. Subsequence is a, they may be empty and are allowed to overlap. Okay, choose two subsequences, each preserving the original order of elements. That's what a fucking subsequence is, right? And let X be the bitwise XOR of all elements in the first subsequence, Y be the bitwise XOR of all elements in the second subsequence. Return the maximum possible value of. But guys, I have a doubt. Wouldn't wouldn't common elements get cancelled from here and here? Do you guys know what is XOR? Do you know what is XOR for two sets? If we have a set A and set B, XOR is A plus B minus A intersection B, I think. Is it XOR? You cannot have in both. You have to either be here or here. That's XOR. You remove common things. That is XOR. Mutually exclusive. But this is not this XOR. This XOR is just binary XOR. Did they even told that? XOR of all elements. And then what is XOR Y? XOR means what is XOR? The XOR of copyright. They made a shitty. I mean, I don't get it. Like, why don't they say it is a bitwise XOR? Where did they say XOR means bitwise XOR? Here they told bitwise XOR, but then this notation of capital X4, where is it like it's a bitwise XOR? So we have two subsequences. Okay, written the maximum possible value of. So one observation is if you have a common element in first subsequence, comma second subsequence, you can just remove it. Now the problem becomes maximum XOR of some subsequence, right? Because see, you have some elements here, and then you have some other elements here in the first subsequence. Common things can be removed. Now it's just some subsequence, right? Because you have some subsequence XOR, you have some subsequence XOR, you want XOR of whole. XOR so is it finding XOR of maximum XOR of some subsequence? Why? Let's say you have subsequence a b, for subsequence 1b, some a comma common, these are the elements, this is b comma common, let's say. So common can be removed from both sides for any subsequence, and then you have a union b, which is nothing but just some subsequence, right? So any subsequence can be divided into two subsequences. So they are just asking you to find the maximum XOR of some subsequence, that's it. So they have unnecessarily complicated something because people may read the problem and leave, right? So let's just check it. 3 is a subsequence, and that's the answer. 5 7, take 5 comma 7, that's the answer. So is it finding maximum XOR subsequence? Now that's the question. Now is it just finding maximum XOR subsequence, guys? So now we have to study. Recently I have done a good video for XOR subsequences. This is that video, Coach Chef's today's contest. Go watch it, and maybe you can learn some proving techniques. Maybe you can learn what basics. Maybe you can learn something else too. Basis is, to prove it, it may be a bit difficult because they're using some vectors things, but then to guess an algorithm, it's not too difficult. Okay. So now if you have XOR basis, how do you find? So what is XOR basis? So we want to find all possible subsequences, right? All possible XOR subsequences, right? We want to find all of this. So what can we say is there are some numbers, okay, b0, b1, b2 up to so on, let's say bl, and these are enough to form all subsequences that can be formed. So such things are XOR basis, okay. See, if you guys are thinking, okay, 4 is not my thing, I just wanted to see LeetCode 2 or 3, don't be like that. No, just because things are not too difficult. So we want XOR subsequences for all things. But then there is something called XOR basis that says just these are enough to form all subsequences. Because if you take subsequences in this, that's enough. You can form anything from that. So this small number of things are XOR basis, okay. That those things are called XOR basis. Now if you have these things, let's say you have these things, now how do you find? So let's say you are given these things, okay, I'm simplifying the problem for you. Let's say you're given these things using which you can form anything. So let's say you can imagine these XOR basis things as 1 2 4 8 up to so on. Let's say you have two powers. With just those two powers, you can form any XOR, right? You can take some bits, you can take some bits, but then you can form anything, right? XOR bases are like some vector transformation on the bits, okay. Let's say bits are just coordinates in 3D space. You have 3D space, right? In 3D space, let's say x comma y comma z, you can only take 0 comma 1 0 comma 1 0 comma 1. If you are looking at like that, maybe you can have some other spaces also, right? So But even if you have other spaces, the dimension will not change probably. It will still be three-dimensional, right? That way, here you don't have bits, but then you have some array. But then you will get these things which are enough to form anything. Do you guys get what I mean? Like these elements are enough to get anything. So now let's say you were given these things. Let's say you were given, uh, and it's also true that their first bit differs. You can form such elements where the first bit differs. Like if you take 1, 2, 4, 8 up to so on, first bit always differs, right? Maybe I'm just giving you this knowledge, okay? It's not knowledge. Before you study XOR basis, let's say, suppose you have XOR basis such that this will have highest bit and then this will have smaller bit and then, I mean, this will be very big. Okay, this will be very big. Like its most significant bit is different from all of them have different most significant bits. Okay, all of them have different most significant bits. Okay, so now given these things, how do you find maximum XOR is the question. You have to think, you have to solve this question. Even if this is XOR basis, you must solve this question. Okay, given these powers, given these numbers, what is the maximum I can form by taking some of them? First thing, you must take the highest significant bit, right? Must take BL. So now you have, because it's so if you are looking at this, let's say this BL is active here. You have to make that one. Okay, and now you have to think, if you can make any of these things as one. You probably cannot. It depends on BL minus one. Where will this one start? If this one is starting here, that means you can make that one. If even if this was one, even if this was already one, you can just leave it. So what do I mean is, so you must take BL, right? So let's just must take BL. So now BL have some ones, some zeros, some ones, up to so on. So now you're thinking, should I take BL minus one or not? Okay, BL must be taken. BL must be taken. Now this is your answer. Now you have to decide if you have to take this or not, because you can make these decisions from behind, because they all have MSB different, right? With different MSBs. So now BL must be taken. So these things must be. This is how you have. Now when you come to BL minus one, you will check that bit here. BL minus 1 has its most significant bit, right? If this is 1, you should not take that, because no one else will help you in affecting this bit, right? This bit will only be affected by. So, to find the maximum XOR, we are coming from most significant bit, because you cannot compromise on most significant bits, because they are much important than everything else. This one thing is greater than everything else. Why? 2 power n is greater than 1 plus 2 plus 4 up to so on 2 power n minus 1. For that reason, I have to give much more importance to these bits. So because of that, BL must be taken. Now we have something smaller. So if this is 1, you cannot take BL minus 1. If that is 0, then you must take BL. And if you must take BL, you will add that BL to your XOR and then you have something again. So you can just continue this process, because and then you will know, okay, should I take BL or not? Should I take BL minus 1 or not? And then you will know. So done. So you must take this and then you will decide based on the value you have, adding this will affect this bit or not. Based on that, you will have add that, because if you add that, that bit is 0 and it remains 0. Whatever you add, it doesn't matter. So should you add this or not will get decided. Should you add this or not will get decided initially. You must add that, and then should you add this or not can be decided greedily. And after these two, you can use the value you have, and then you can decide for the next thing. So it's not that difficult, right? Okay, coming from most significant bit, maybe I can decide what's the subset. So now XOR basis. For now, let's just Google it. Okay. So when you see it is XOR basis, you should not leave the problem because it's XOR basis. You should solve this, because you won't find this online, right? This is a simple thing. Maybe coming from this side works. So for XOR basis, let's Google. Okay. Okay. How do I know XOR basis exists? Maybe it takes some time. It's not that easy. But maybe if you try, if you try that, Guys, like the video. Maybe I have to increase my brightness so you guys can see me properly. And use light mode. If I use light mode, people may get offended. Okay, see, now think of it. How can you think XOR basis exists? Because you cannot always keep panicking like, okay, there is some topic you cannot do, right? Always. So you have to think. We have so many elements. We have n elements. But then still, if you can solve some things nicely, what can we say? Are there some nicer things in this? Because we have n elements. But then, you know, if 1 2 3 1 2 4 up to so on all the bits are present as individual elements, only they matter, others doesn't matter because anything can be found with them, right? If you have 1 2 up to so on 4 up to so on, so now you can think, okay, if 1 2 4 up to so on are there, then those are the only required things. But if they are not there, can I still get some other things that can be used to form anything? You can still think of that, right? Can I still think of something that can be used to form anything? You can think of that. Maybe there are some small elements that can be used to form anything. Plus, all of them are must be needed because without this you cannot form something. Let's say. So now you know what these type of things are. They are like bits. Like you can form using all these things. Probably you cannot form this. That's why you also want that. Using all these things, you cannot probably form this, right? Because if you can form this with this, then it's not needed at all. If you can form this with this, so now you can even think of how to make these things. Okay, let's say you have an array a0, a1, a2 up to so on. So try to guess an algorithm. See, time runs very slow. If you don't, I know people saw LeetCode contest in 15 minutes or 30 minutes because I can see it's still going slow. I don't know why. Uh, Try to guess an algo that takes this array A and gives us basis B. So you have to see that when you are adding a new element to the basis, that means that cannot be formed with any of these things. And and then you must add that. So now the question is, can you check if you can form this thing with all these things? Again, come from most significant bits. If the most significant bit is already existing somewhere here, then you must take that bit. Why? The fact that these are all having different MSBs, you can decide when a new element comes with the most significant bit, should you add this or not? And then once you add that, the thing will change again. Now again you can decide, uh, because you must take that because that's the highest MSB, right? So wait, what do I mean? Because when this thing has MSB something, so when you have AI, okay, let's say you have, let's say you have basis for 0 1 up to so on I minus 1. Let's say you have basis for this thing. Okay, now you have AI. You should decide if AI can be formed with old basis, because then AI doesn't correspond to basis because it can already be formed with the old basis, so AI is useless. Then do nothing probably, else add AI or AI or old, I mean AI to basis. This is the algorithm. Maybe we won't add exactly AI, maybe we will add it in a better format of things having MSB differing thing. Okay, this is how you find XOR basis, because still it's not too difficult. It can be considered as a topic because XOR basis is a bit famous. And you have to guess, maybe there is something like this from the question itself, if the question can be solved simply, easily. So I have written this algorithm some time back. So what do? I will write the algorithm again, right? So we are here. I want to find this basis, right? So there is a way that I already know that you can always find these basis things with differing MSBs. Okay, there is a weight with differing MSBs. So if we know that thing as true, maybe I'll just keep int basis of till how many do we have these bases? 31 or 30, 30, 31. 2 power 30 is bigger than that, right? Equals to a 0 or something like that. Means there is no basis with MSB as this or not. I'm trying to store in this. Okay. So now we have our nums array. Okay. Let's say let it be x nums. So now I want MSB, let's say most significant bit. Int MSB of int n. How to find that? J equals to 29, j greater than or equals to 0. Elements can be 0 too. Return -1 if it is 0. Else, if n and return j. This will give us most significant bit. So our assumption is there is a basis with different MSBs. So if there is a basis with different MSBs, then it's easy to check if uh, AI can be formed or not. Why? You have AI. Can you use some basis which has bigger MSB? No, because if you use that, there is no way you can remove that, right? So you cannot use any of them. You cannot use highest MSB basis because if you use that, there is no way to remove that. You cannot use the next one too. And then when you have a basis here, you must use that. When you must use that, again things will change. After things change, you will follow the same process again. Okay. So so you guys can see, right? So so we have this x. Okay, we have that x. So what is the process? You have to come from j equals to 29, let's say. I'm coming from this side bit. J greater than or equals to 0, j minus minus. We have some basis elements already found before this. Okay. We have basis for before elements with differing MSBs. Okay. Because they are differing MSBs, I'm storing them here. So with most significant bit 29, if there is a basis vector, the basis value that will be here in this. Okay. So now we are coming from top. We have x. If x is not set, if x and j, if x is not set or x is set, okay. So if x is not set means what? Or or you can just compare. Or you can just compare. Okay, we are coming from big things, right? We are coming from big things. So if x is set means we must take this basis, right? So I'll call it val. Okay. Oh, or else I can just use x itself because it's not reference based, right? So if x is set, if x is not set, we are coming from that set. Means you cannot use this basis at all to form x. Okay. You cannot use this basis at all. You do nothing. But if this bit is present, you must take that. You must take that basis because if you don't take that basis, there is no way with smaller basis you can form this thing, right? So I'm taking that basis, but taking that basis will make this x s to be this thing. If you take that basis, it will change the x a bit, and then you proceed further. But this basis will not change its previous bits because all of them are zero, and basis will only have some other things on this side. So it's fine. In the next things, you will keep forming. So now, after doing all these things, okay, you should also make sure that you should also make sure that okay, if if basis of j exists, then you can do that, right? If basis of j exists, then you can do that. But if that doesn't exist at all, then you cannot possibly do that, right? So means this basis of j is not there because initially nothing is there. You got an element, this bit is set, but then this basis is not there. If that basis is not there, then what do you do? probably make this value of x as this itself as basis maybe, and then break, make basis of j as x, and then break. Okay, maybe probably this is enough. Why? What happened to x so far? It had just taken some previous elements. XOR this is nothing but you're just taking help of previous elements, and then you are not able to form this. So maybe this is a new element for basis, right? So now maybe this algorithm works, and this algorithm gives us all the basis vectors. Maybe this just gives us all the basis vectors. So now what should we do? So now, because we have all the elements, so now we will again try to form. So now we have basis. Okay, now we have basis. So do we have people? Are you sure? I think there's a way always with different MSBs. Okay, I think there is a way always with different MSBs. So we just maintains those things to proceed further. Okay, uh, these elements may not exist in the array. These basis elements may not exist in the array, but then they can be formed with some subset of array. Okay, that's true. So, but still, this is the best explanation you can probably get online, because see, my ways are very clear, right? I'm trying to, we have an x, I'm coming from here, we have some existing basis vectors. If all of them are zeros, we can't, we need not do anything, but we have one now. Now we have to decide. We cannot use previous things at all. If this thing is there, we must use that, because we cannot use previous things. If this is there, we must use that, and once you must use that, these things will change. But if that is not there, you cannot proceed at all. That means you probably got something which cannot be formed with any of the existing things so far. And you're asking me how there exists something with same MSBs, right? Maybe you can always make it like that. Otherwise you can maybe prove that they are not tight or something like that. Okay, it comes from matrices, it's not that easy to prove. Maybe it is easy, maybe I'm not able to prove it here right now, but then uh, let's go further. Okay, let's say you have some basis thing, you can always make them as lesser things. Okay, I think it's like this thing in vectors, right? You cannot have more than n independent vectors, right? It's of that kind. It's like independent vectors kind of thing. Like if they are independent vectors, maybe you can make each bit to be that, right? It's something like that. Okay, it's independent vectors type of thing. So now we have to find maximum XOR. There is no algorithm. The same thing we have done. Let's say current maximums are be 0. Okay. For j equals to 29, j greater than or equals to 0, j minus minus. So now we are again coming from the max bit. If this bit is not set in max XOR, means what should we do? So one okay, if basis of j is present, then maybe we must add, then we should not do anything. Okay, else why we should not do anything? If basis of j is present, we should not do anything. If basis of j is not present, then also we should not do anything. Then we cannot do anything. Then we cannot do anything. I mean, we cannot do anything in the sense we will just skip to the next thing, because that is one already. We'll just skip to the next thing, next bits. Okay, else, so now this is not set. If basis of j is there, you will set that. You will make max XOR with basis of j. So once I consider basis of j to be must be taken, so now we have this must be taken. I'm adding that to max XOR, and then we'll go to smaller things again. Okay, when basis of, so now max XOR, why I'm only checking basis of XOR is, okay, I'll just if basis of XOR, basis of j equals to 0, continue. If that is not there, we are continuing. By now we are trying to focus on what basis should be taken to form, what basis should be taken to form maximum XOR is our question now. So we are coming from the bases from this side. If that basis If max XOR is its bit is already set, taking that basis will make it worse because smaller basis cannot help at all. So do nothing. But if that is not present, you must take that. Okay. So in that way, it's being done greedily. So the only assumption we made is there is a way to form basis with different MSBs. Okay, this is the one only assumption we made. That seems a bit reasonable. So maybe you can guess this and then solve this in contest. Okay, but I'm telling you this is involving knowledge. But code forces has much better problems where you need not know something like basis. Okay, code forces has much better problems. Maybe there are very difficult problems. Like I was solving today. The problem I was solving today, you have some array, and then you can take some length less than or equals to d. You can take some length less than or equals to d, and then you have to reduce max element by 1. Only max element will be reduced by 1. Only max element. That was the problem. And then you want minimum number of operations to make it 0. Seems simple, but then the length of this is restricted. If the length of that is not restricted, it's just max is the answer. Why? Max should at least reduce by 1 in one operation, right? And then you bring everything down. So this problem probably has less knowledge than this problem, where this is a bit difficult problem, I guess, right, on code forces. But then you have to see what you want. Okay, leave it. We have to win this, not win this contest. We have to solve all the problems in this contest, right? So I will submit this now. Accepted. We got 671 test cases passed. I hope my explanation was good enough because see, we did everything on our own. We did everything on our own, right? We didn't even Google basis code, even though I could have done that. But then I saw these maximum things possible from here only. But then I won't prove how exactly we can prove that we can have with different MSBs. Okay, I won't prove that. We can think of that as each bit to be like some coordinate in some n-dimensional space kind of coordinate. And now because they are independent vectors, you can probably make them as each bit to be different kind of thing. Like now it's like minimum independent vectors kind of thing. Okay, because if the dimensions are less and you have so many vectors, you can probably find a set of independent vectors from them, and those independent vectors are enough to scale anything, right? Because XOR is nothing but addition of two things, 0 plus 1. In terms of modulo 2, if you take base modulo 2, see, addition over set of 0 comma 1, over that set addition is same. 1 plus 1 is 0, 0 plus 0 is 1. Among that set, now you have a z power. This is, let's say this set is z. Now we have z power n vector space. In this vector space, you have so many things given, but then you can choose some things in this so that uh, you can choose some things in this so that they are like non-independent vectors. Okay, non-independent vectors. That's what basis is a bit. I hope I gave some good explanation for basis in this. Yeah, now we have to judge how difficult was this logically. How difficult was this problem logically? Okay, if you have some bits maybe coming from highest significant bit, because those bits are most important, right? In bitwise representations, highest significant bit is much larger than everything else. Not much larger than, it's one larger than everything else combined. 2 power n is equals to 2 power n plus 2 power n minus 1 up to so on. All of this is 2 power n plus 1 minus 1. How? 1 plus 2 plus up to so on 2 power n. So what I'm saying, 1 plus 2 plus 2 square up to so on 2 power n equals to 2 power n plus 1 minus 1. How can you prove this? Maybe add plus 1 here, minus 1 here, and plus 1 here. Okay, this 2 will become 2. Now this 2 will become 2 square. This, all of them will become in similar way 2 power n plus 1. So what does that mean? This bit is much bigger than everything else. Everything else add up to just this less than that bit. So this bit is very important. So you have to see if I can set this bit. And you need some basics, XOR basis knowledge, but once you have that, it's logically very easy, right? Okay, I have to go to that bit maybe. Now if I go to that bit, I have these XOR basis things. Okay, if that XOR basis can help this bit to become active, then you must take that. And then now you have smaller basis things. So now you have this that must be taken. So now these things are some ones are there. Now when you take that again, you decide if this is 0, you must take that. If this is 1, you should not take that. And then you have to proceed. Okay, That's it. Logically, it's being very easy. So if some of you might not have solved this problem, you have to really think why you are not solving. Did you get scared of the problem? Have you How hard have you tried? How much have you tried? You have to question all these things before making any. Oh, I can solve till q1 comma q2. Because if you keep giving contests and if you keep telling yourself that I can solve only till q1 comma q2, your brain cannot. The next time, see, if you always, if you are always telling like that, it will become much difficult, okay, as you go further. Because uh, confidence, optimism is much more important in solving problems. So let me read this problem too. So how I have solved this problem was, I thought before making, I thought first we have to subtract maximum itself. That is obvious to say, right? And then we can say some maximum, and then we can say we can make all the maximums to maximum minus 1 first, and then make all the m minus 1s to m minus 2. So now we have another problem. Even if you just keep 1 comma 2's, you can think of that problem. Okay, some 2's are here, some 2's are here, some 2's are here. Using d things, what is the best? So now the problem is, first you have to make all max to max minus 1's, and then you have this group of indices. Now you have to make all this group to something smaller, and then you have many things, and then you have to make all of those indices to something smaller. So now the question is, if you have some elements here and you can only take d things at once, what is the best way to do? You have a greedy way, right? But then the problem is, you come from m to m minus 1, you get new indices. So the problem is, some new indices keep coming, and then you have the greedy question. Take these things, take these things, take these things. So just this level of difficulty itself is very difficult. This itself is division 1e. See, this is the solution. Maybe now doing this is not that easy. Maybe now add a new element and then take these things. Maybe it needs something. I tried some n root n thing. What I tried was, if d is greater than root n, I have some elements, right? I'll take first element and then I go to plus d, plus d, plus d. If d is greater than root n, you can't keep going more than root n times. That's why I did that. And when d is less than root n, I'm trying to brute force and write some n into d algorithm. Okay, that would be working, right? N into d. I know you LeetCode people will get scared, but this is much difficult problem because it's division 1e. Okay, so but still you can work on that logically, is what I'm trying to prove. So do we have viewers? Like the video, guys. One minute. So now time is running down. We are at 58 minutes. Can we solve it? This one has no logic. 6 points. Now let's see if this has some logic. It's hard. If there are any girls watching and you are dreaming to date some guy who can solve LeetCode hard problems without looking at ChatGPT or Google, you're looking at him right now. Okay. Uh, you are given an integer n representing n teams. You are asked to generate a schedule such that, so we are given an integer n representing n teams. So each integer, okay, the integer n representing n teams, I don't get them. What they are trying to say, integer n representing n teams. N represents n teams. How can one number? Okay, I don't know. Okay, let's leave that. You're asked to generate a schedule such that each team plays every other team exactly twice. So we have some rules, we have n teams, we have some rules. The rule says each team plays every other team exactly twice, it seems. Once at home, once away. IPL. There is exactly one match per day. The schedule is a list of consecutive days. And schedule, what is the problem? Schedule is a list of consecutive days. So every day there is exactly one match. Okay, every day there is exactly one match, and then schedule is list of consecutive days. Okay, we have line consecutive days, that's a schedule. Schedule of I is the match on day I. No team plays on consecutive days. So this is the one weird condition we have for IPL. Maybe in our real IPL also this holds true. Maybe, I'm not very sure about that. Not a very big fan. of being fan to someone. Written in 2D array schedule, where schedule represents a home team, schedule represents an away team. So it's a good problem probably. I can act like calling every problem a shitty problem, but then this is a good problem. You are given some rules and then you have to find some arrangement, some schedule, and then if it is impossible, you have to say that too. If it is impossible, you have to say that too. Okay. So this is a good problem. You can think when it is possible, when it is impossible, right? When n is 1, n is greater than or equals to 2. When n is 2, what would you do? So you have how many matches? Each team plays, you have 2 times n into n minus 1 matches, right? Each team plays the other team twice. Sorry, you have n into n minus 1 matches. Why? Number of ways you can choose two things is NC2. NC2's definition is that. NC2 means if you have n things, number of ways you can choose a subset of two things is NC2. NC2 definition is that, okay? So, but then NC2 value is n into n minus 1 by 2. That we can think of later. Okay. So, we have to make ordered pairs. A comma B means each scheduled A comma B means home was A, other was B. So for some particular team RCB comma CSK, we have two matches. Okay, one at BLR, which is RCB. Okay, I'll make it like this, which is RCB. I know the viewers of LeetCode are like a bit low, right? That's why I'm just writing RCB comma CSK. I know we don't care. We don't give a shit about RCB comma CSK. We will just make it A comma B. But then LeetCode people, right? We have to make them excited. Otherwise, I'm just joking. Okay. So we have these two types of matches. So number of let's fix RCB. How many ways can you fix RCB? If you fix the first team, you can do that in n ways, and then for each of that you can have n minus 1 things. Okay, so that means if you fix RCB will be playing with other n minus 1 things, right? Other n minus 1 things. So why are we not fixing other game of RCB? That will be fixed when CSK comes here. Maybe there we will count it. So we are counting ordered pairs by fixing RCB. Now we have a restriction. So if there are only two teams, you cannot probably. So now we have these many matches. Okay, if there are only two teams, you cannot solve this problem. Why? However you do, RCB plays on consecutive matches, right? So when n equals to 2, it's impossible. See, this means nothing. This means every day someone should play. This means nothing. This means nothing. This will just fix number of matches and what those matches are. It will just fix that. So now we have an idea. If you fix RCB, you will have n minus 1 things. Now there is a constraint. That this new one, no team plays consecutive on consecutive days. This is the only constraint that actually makes n equals to 2 impossible. Why? N equals to 2, it's impossible. So if n equals to 3, they are giving you a schedule. That means probably for n greater than 3, it's always possible. Maybe for n greater than 2, it's always possible. Why? Because we have, for each RCB, we have these many things, right? But then again, the next thing comes immediately. That's making it a bit difficult. Right? That's making it a bit difficult. So that's the problem we have. So now we have to think of a way. Probably it's always possible for n greater than 2. So now we have to think in a way to arrange these things so that RCB doesn't come at all. Okay. One thing is easy. 2 days of RCB playing in hometown, that is easy. Why? You have RCB hometown list, right? RCB, okay, not this. if you fix RCB, let's say if you fix RCB, you have RCB playing with team 1, RCB playing with team 2, RCB playing with, you have these things for up to so on n minus 1. You have these things for all teams. You have this list also for CSK. If n greater than 1, probably these things will be greater than n greater than 2. These things will be greater than 1, right? So what can you do? Maybe you will take first thing here, first thing of CSK up to so on, first thing of everything, and then you come to second thing of this, second thing of CSK and so on everything. With this, you can guarantee that RCB home will not come twice one after the other, right? You can guarantee that RCB home will not come twice after this. Why? RCB came, RCB home will not come again because something else coming, and then RCB home coming. But then the problem is, maybe after this, if CSK also has RCB in first, then you cannot take RCB and then this thing. So this is the only thing we have to think of. Otherwise, we have the solution. We have take this one of every team and then take the next thing of every team. Now we have to think. Now we have to think again. So maybe let's think of this. Let's think like this too. Okay, let's think like this too. Uh, 1 minute. Let's think like this too. Okay. Maybe let's try to form. See, here I am trying to find a whole schedule pattern itself and then output that. But let's try to go back to let's try to use indection. I know I can just do this too probably, but then I want you guys to try this one too. If you have a way, if you have a way to schedule n minus 1 teams, can you schedule by adding a new team now? This is a simple induction question, right? This is a simple induction question. Let's remove RCB entirely, all the home and the other matches. Let's say you have this schedule. Okay. Now you have other schedule. But then now if you're adding RCB things in between, you have to be careful again. You have to be careful that you cannot, when you're adding RCB comma CSK, you should be careful that CSK should not come behind CSK. So this is also not that easy. So let's go and try for the whole thing itself. Okay. Whole pattern itself. One possible pattern can be take first team here, take first team here up to so on. But then we may face this problem, which happens with n equals to 2. Okay. So now let's again see a bit. So let's say these are like an increasing order. Okay. 0, 1, maybe 0. For 1, you will miss 1. Okay, because n minus 1, right? For 0, you will mix 0. And then you will have up to so on. So now we need a pattern. If I take this up to so on, then it might not work that. It might not work that. This 0, 1, after this 0, 1, we may get this thing, right? That's the only problem. So let's look at our pattern itself. We have 0, 1, and then we have 1, 0, and then we have 2, 0, 3, 0, up to so on. Okay, and then we are thinking 0, 2, and then we have 1, 0, 1, 2, right? 1, 2, 2, 2 is not possible. We have 2, 3, and then we have 3, 2. Sorry, 3, 1 is it? 0, so I'm looking at the second matches now. 0, 2, 1, 2. If I look at third one, 2 0, 2 1, 2 2 2 2 is not there, 2 3 up to so on, right? So now we are taking second matches, 2 comma 1 it is, 3 comma 1 up to so on. So this is our possible pattern, but then here what happens? On home ground, no team plays consecutively. Why? Home ground 0, 1, 2 changing. Home ground is changing, but then this can happen. Only that can happen is the problem. Okay. I'm writing our pattern down and then I'm saying what's the problem in our pattern. Our pattern has this problem of n is very small here. The only problem we face here is 0 comma 3, 1 comma 3. Why? Because for 0 0 is missing, for 1 3 is missing, but for 2 2 comma 2 is missing, so 2 comma 3 2. Okay, and then for 3 it's 3 comma 2, for 4 it's 3 comma 2, 4 comma 2 up to so on. You can see that 0 comma 3, 1 comma 3, 2 comma 3 is right, but then from 3 onwards it's 3 comma 2 because 0 1 2 all there, right? So if you're seeing here, where is the problem? Where is the problem coming? This will have n comma 0. This n cannot match with this 0 or 2. Okay, that n cannot match with 0 or 2. So where is the problem occurring? Here you have this thing as a problem. Here you have only this thing as a problem, right? Other things doesn't match at all because for other things 0 is fixed, but then this is different. Wait a minute, wait a minute. All of these are problems, right? All of these are problems. So maybe we can just choose in a better way. Let me fix 1 minute. Maybe let's try for better patterns. Okay, maybe let's try for easier patterns. Let's try for, let's say n is even kind of thing. If n is even, can I always keep no, wait, I thought, okay, here home ground will not match, but then all these things are matching a lot, so we cannot do this. I didn't see this at all because I thought, I proceeded to explaining this by thinking only one conflict is there, but then 0 matches for all of these things. So let's not go with this. Okay, let's not go with this. Let's think some more time. So let's try for a mathematical pattern. Okay, let's, instead of all these things, let's try for a mathematical pattern. Okay, so I comma j, right? We have to write these things. We have n minus 1 things. Let's just go for that. Maybe always, maybe I plus 1 comma j plus 2 or something like that. Like increase this by plus 1 and maybe increase this by plus 2 because n things are there, 0 to n. Let's not worry about them in some way. Okay, if you're doing like this, you can just say, you can see that these numbers are all, this and this cannot be equal, but this and this may be equal, right? So maybe let's just keep it like this. So maybe let's just keep it like this. I want to make sure one is even and one is odd, so that, so maybe I'll just keep it odd and one is even. I'm just guessing few things, and then maybe plus two plus two. I'll do this. If I do this, what can I say? These two will definitely not be of same things, right? These two will definitely not be of same things. And then when we do plus two comma plus two, if n is greater than 2, we can make sure these two are not equal, and these two are anyway not equal, and then we keep going. Okay, maybe this is one pattern, right? Because now I need not worry this being equal to this or not. Why? I'm making sure this is even, odd, and this is even. So I really thought this is done because I thought, okay, only one thing is violating, so maybe I can swap that, but then this thing has many things violating, so let's just skip that. I wanted to explain it because I thought, okay, this is thing. But then if I have seen that, I would not have done that. Maybe now I can just think of something like this. But this is very difficult when compared to the next thing, right? Something guessing something like this, something mathematical like this is a bit more difficult, right? Or maybe something like this also works. 0 comma n and then 1 comma n minus 1, or I don't know. But that seems difficult to write. So now, but here do you see, 1 minute, even this will solve it or not, we have to be very careful. We have to conclude all the things, right? So I have to be clear, 2 times I plus 1 comma 2 times j. Let's say this is what we are looking at for all possible I increasing and j increasing. For all possible I comma j, like let's say you try to increase I one by one, j one by one, and then you have these things. Okay, so if you write all of them somehow, maybe let's just increase I first and then increase both maybe. But then if you're increasing both, that's a problem, right? Or maybe you can increase both like this. Maybe you can increase both like odd plus I, even plus I. Maybe you can just increase like this. Okay, some or take some odd, take some even, and then increase, keep increasing them. Because if you keep increasing them, what happens? You need not worry this odd matching with this even. Maybe this thing. Let's look at this thing. I know I'm complicating. Maybe this much is not needed for lead code, but then maybe there is a simple solution. I don't know. Maybe you guys can just see how IPL patterns are there already. I don't know. But let's think of this thing. Take some odd number, take some even number, and then fix these two odd numbers, because now you see for all these patterns, for all these pairs, something is fixed. What is fixed for all these pairs? If I keep increasing I, we can get n things, n different things, but not n by 2, because 2 times I, right? But e minus o is fixed. For all these numbers, e minus o is fixed. Maybe I'm complexing. So we can have n such things where adjacent things are not at all equal. I'm trying to use even and odd. Maybe we can just use maybe you can just take, maybe because it can be solved with n equals to 3, maybe you can just do something like, maybe you can try for inductive things too. Okay, maybe for inductive things too. Let's say you have three things now. A new team is coming. Okay, a new team is coming. That's also not that easy, guys. We are not able to solve it. 20 minutes. What happened? Maybe that will also work, Jay Patel. Maybe that will also work. But then, how are we so sure that that will always work? Like maybe it gets stuck in between. Maybe we cannot form such a team. Maybe finally it becomes what all matches you left is like same team matches. So we have to do one thing is clear. If we can think of an uniform way, that also can be done. If you can think of some uniform way where you can do things uniformly, that also will give you possibly keeping some team same teams far apart, right? Maybe keep doing something uniform, that would also work. So when I do plus 2, I mean like modular reminder kind of thing. Okay, so now with this it's mostly possible. Why? You have odd comma even, and then you have all odd comma even with this difference, and then you take this being 0. Now you can start with, now we can start with e minus o being 1. But once you start with this, okay, once you start with this, let's say the end of the previous thing and the start of this are being same. If the end of the previous thing and start of this is being same, maybe then you can start with e plus 2 comma o plus 2. That will probably not match with this 2. Okay, that will probably not match with this 2. if one of them is matching. So maybe, and then you can form, but then this is also complex. We will not code such complex thing. Guys, we need something now. I'm not able to solve this. I can probably not solve this too. So we have 20 minutes. Do I fail? Now, let me try this and then come back to this because I want to solve my first lead code contest fully, right? Let me solve this and then I'll come back and then I'll solve that too. Okay. So now what is this? Arrivals will be within this, right? Arrivals will, all the types will be within this. So I will maintain, I will just maintain frequency of within the window. Frequency, maintain frequency within the window. Okay. I wanted to clearly prove, but then light now. Maybe this is optimal. Okay, maybe this is optimal. Why? Why? Why this greedy is optimal? The problem is independent for all types. Problem is independent for all types, right? Why? For all types, it's independent. If you are not taking some particular type, that means that type has occurred many times. So probably you can take the first type always because it's a window, right? That's affecting. Maybe we'll always take the first one and then greedily remove the first time whenever something fails. Maybe that seems greedy, maybe that seems good, right? Why removing the last thing seems good? Because this is anyway will be removed. So instead of removing something here, removing this would be better. So maybe greedy works. So let's just go for it. Okay. Because it's dependent on each type, we don't care. We'll just go now. Frequency of types of define n to be 1 1 0 0 0. This will have frequency, let's say, of our window. Okay. So now we are here. Okay. Um, let's add our new element to our frequencies. Okay. So this type frequency increases, right? And now we will remove our. So I'm trying to make a new window. When I'm making a new window, I have to remove the old guy, right? What? Who is the old guy? One minus W. He is probably the old guy, right? So we are trying to make the new window. Currently, we have frequencies of previous window. When we are looking at our window, maybe the last guy should be removed, right? The guy who is outside the window. 1 minus W is outside the window because our window comes from 1 minus I plus W1. So if it is existing, we are removing that. Now, only our type's frequency might have changed, right? Might have increased. Someone else's might have decreased, but only ours might have increased. But if this is plus plus, maybe this guy also fails. But then only this is failing. So now if frequency types of type is greater than m, means we will just reduce it minus minus and then we will increase our answer because we are not taking it now. Okay, and then we'll return our answer. So now we have 14 minutes to guess our schedule. Can we do that? Am I wrong? Did it pass? We got a wrong answer. Wait, here itself I did 0. Okay, here the answer is 0. But what was the test case that went wrong for us? Wait, did this guy solve everything in 18 minutes? Damn. Maybe I'm doing too bad in LeetCode. Or maybe I'm trying to explain, I don't know. What went wrong here? Yeah, this continuous three things are there. Window is three. Wait, what went wrong? How did it go wrong? So we were not given size of array. That's the fucking problem. I thought size of array was given to us, like in the with the W. But still, we are not solving. It's independent for each types, right? So we are trying to greedily remove our lost type, right? Because removing that is better. Because in the next windows, this comes. Guys, we have 11 minutes for the previous thing. Not solving is bad. M is 1 means you can't take this. 1 gone. W is 10. Guys, tell me error now. Sad bro, Pradeep. Yeah, Jay Patel, that may be right. I have told you that. I mean, we cannot be better than them, right? Because we cannot be better than them because we want to minimum number that can be discarded. So if ours is right, we cannot be more better than them. I minus W. Why is output 0? In this 10 itself, we cannot have three things. So remove 3, 3. Guys, what's wrong in this? You added it. That's why I'm subtracting it, right? Should we do this thing? So it's zero based index only, right? We are not able to solve it in 5 minutes. We are done. First contest happens, guys. First contest we face pressure, right? Discarding this is only optimal. That's why we are only removing lesser things. Removing lesser things, how are we wrong? Thank you, Ash. Thank you for helping me out. Damn, why did I not miss that and then I'm not able to know it at all? Yeah, I'm removing it here, right? So I should not add it. Accepted. We have 2 minutes. Can we make it? What is 3? How is answer for 3? 0, 1? Wait, what's the answer? It's not possible. Someone told any odd it's impossible, but how can I see that? Okay, if any is even, is it always possible? If any is even, dun, 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 dun. Mr. Raindrop falling away from me now. Guys, now we have this. How to solve this? This seems a bit fun, but it's complex. Bam, 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 ba, bam, 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 ba. We are not able to solve all. We can't solve it in 41 seconds. 30 seconds. We surely cannot solve it now. N equals to 5, it's impossible. So n equals to 3, it's impossible. But n equals to 5, it's possible. Means if you have more things, it's possible. Maybe we'll flip it, maybe we'll do that. Because here I was trying to move two things, right? After this pattern itself, I was trying to move shift twice because we have two things. But if you go twice, none of them will match. Maybe this matched here, maybe this matched here. But then from here, none of them will match. So we have this solution where we have this, we can shift this thing cyclically, let's say. We have this last two our start if one of them matches we'll do plus 2 maybe then now this matches we'll do again plus next thing from there if we start it works out e equals to e minus 4 equals to 0 e minus 4 equals to 1 up to so on we go and then we do o minus 1 equals to 1 and o minus 1 equals to 0 or like that. So this one will work for n equals to 5 but there is there a better solution? Do you guys see what I mean? I'm fixing e minus 4 and then I will do plus 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 cyclically. So now last two things are there. Now from the next thing, I'll keep doing next things. And then if them matching, I can just shift from here. Yash Mohta has told try to keep all the whatever last two is not there, take them and then keep them here. But then I don't know if it makes us fail at the end, right? We don't know if it fails at the end. If it fails at the end, like everything, few things are left, but then you cannot keep anything here. That can happen, right? If it is 1 comma 2 and then you have 1 comma 3 1 comma 4 1 comma 5 1 comma 6 you cannot keep anything here, right? We have to do it uniformly. Maybe it works, but we cannot be very sure. I have to pack this up quickly. So guys, I have one solution. If you guys see this, I'm making one odd, one even because then I need not worry this matching with this, right? Odd even, I need not worry this matching with this. and then so this works well. This is a good solution. I'm thinking it's complex, but then that's not that complex, right? It's not that complex. So how do I do it? So first I will print all even minus odd, and then I will print all odd minus even, and then I have this thing, right? We have to return the vector too. So if n less than 5, probably just return vector int, right? Maybe it works. Vector of vector int. Maybe this works. Will this compile? I, I thought it's complex, but then it works. Let this be d, okay? Int d equals to 0, d less than n, d plus plus. So I'm differing the difference, okay? It's actually d less than n by 2. Okay, it's d less than n by 2, so that when I do 2d, wait a minute. D is differing, right? D less than n, instead of doing d by 2, I'll do d plus equals to 2. So now we are going over all odd comma even things, right? But then there will be even comma even. How would I deal with them then later? Maybe later there will be even comma even pairs, right? I have to deal with them too. So maybe then this way is not that great. All odd comma evens can be kept here, but then leave about even or odd. If I just fix difference, is there a way to keep all of them? If I just keep difference fixed, if I just fix the difference, 1 2 1 2. So let me just fix the difference, okay? Then we have uh, I comma I plus d, okay? And then we have j comma I plus 1 comma I plus 1 comma d. So the fact that these two are equal in terms of modular remainder 2, that means that happens for I plus d equals to I plus 1. Only for this it will happen. Two adjacent things being equal, right? Means only for d equals to 1 this happens. For d not equals to 1, you cannot have this and this being equal. Okay? You cannot have this being equal to this two. Why? What does that mean? I equals to I plus 1 plus d means d equals to d plus 1 equals to n, right? So d equals to n minus 1. So only for d equals to 1 and d equals to n minus 1, you can have adjacent things equal. For everything else, it will not happen. Only for d equals to 1 and d equals to n plus 1, this will happen. For everything else, for all other d, you can just keep going, keep going, keep going. And then you have many things, right? Then maybe you can start from somewhere that doesn't matter, that doesn't equal. And then you can keep going like that. But then when d equals to 1, 1, 2, 1, 2, 2, 3, 3, 4, 5, 6, would that work? So guys, how to solve this problem now? How to sleep? Let me think for some time without talking. Okay, I'll get water. Whenever I get water, I'll solve the problem. Right? I'll just get some water. Okay, I didn't get any idea. I wasted a lot of masala in fries. Normally, I would have ate them. Well, I didn't get any idea, but let's think for some time. Okay, we have to solve this problem, right? We just need a pattern. What about like just like I comma n minus I, or I comma j and then do I plus plus. These two will not be equal, and then these two. Can n minus I equals to I plus 1? If n is even, this will work out. Because if n is even, these two cannot match. And similarly, these two also cannot match. If n is even, maybe this works. But what does this mean? This means when they are same parity, right? Same parity. Like I was worrying about even comma even, but then so let's just say there's some being even. Okay. Sum of two things being even. Sum of two things being even. Okay. If sum of two things being even, then I comma, let's say that sum is I. I'll just take these things up to so on. So now any adjacent things cannot be equal. Why? This and this cannot be equal because whenever sum is even, and when sum is odd, we have this already working. Because when sum is odd, one is odd and another one is even, right? So whenever sum is even, this pattern would work. Okay. So for odd, this will work. I thought for even it's not easy. I thought for even it's not easy, but for even just this will work. Why? This and this cannot be equal. Why? This and this cannot be equal. This and this equal means s equals to 2i plus 1, but s is even, right? Also, this and this equal means s equals to 2i plus 1. That cannot happen. So for all even sums, we can just make such thing. For all odd sums, we can just make this directly. Okay. For all odd things, we can just make this directly. So now for all even sums, we have something. For all odd sums, we have some pattern. Now we try to keep those odd sums in between, even sums in between, up to so on, and then we will be done. So right, this seems fine. But now let's see a bit. 1 plus d I plus 1 I plus 1 comma. Okay, leave this thing too. Where are we? For odd sums, whenever the sum is odd, so whenever the sum is odd, how would you do those things? For them, you choose this pattern. I comma, but here what you do? You do I plus 1 comma s minus I minus s minus I plus 1. You do this thing here. Okay. But then the sum changes here. The difference will remain same. Right. Okay, but all the even sums we are able to handle like this. For all the odd sums, we can just make them. All the odd sums we can just make them in terms of the difference, and then we can just all the odd sums will split them in terms of the difference, and then we'll just write them like this. Okay. But because these things are changing one after the other, we can always, if last thing is matching with this or this, it may not match with this. Why? They are increasing gradually, right? They are decreasing gradually. So this pattern can also be merged with the previous patterns. So like when we have this even minus odd being d, we have all of them, but then last thing has x comma y. But then the next pattern is having next d is having x here, y here. That's not possible. X here, y here, or y here, x here, or something like that. Something here matching and also something here matching. Then you can say for sure here it won't match. Okay. You can say here for sure it won't match. Because n equals to 5 would probably guarantee that. Four things are there. Fifth thing would not match probably. Okay. That's not n equals to 5. That's not how it's n equals to 5, but probably for n equals to 5 we will have some greater things. Because here we have, for each sum we have n things, n such things, plus 1 plus 2 up to so on we go till n, where sum is fixed, and then we covered all n possible things. When sum is fixed, this can have n things. So sum is one parameter, I is one parameter, we have n different things. When sum is odd, again we have, when sum is even, sum is odd, n cross n minus 1, right? So here we should make sure that these two are also not equal. When sum is even, it's possible that these two are equal at some place. Then you will skip that. So these are n minus 1 things for each thing. And then you have n minus 1 things for each of these things too. But then skipping that, would that be fine? Guys, we are not solving this. Yeah, you told me that already. Oh, Pradeep is different, right? How many times would you ask, bro? How many times would you ask if I know Telugu? I know Telugu. I am from Andhra, right? So, guys, we are not able to solve this. People were able to solve in 18 minutes. See, Pradeep, we should also be able to prove that easily. Okay. So, I don't know if it works, but then there is some probably some pattern. Probably there is some small pattern. Okay. I don't think this is an LLM. We will solve this, guys. We will solve this. Let's think. Maybe some pattern works. Some easy pattern will work. Let's just take two things to help each other. Okay, maybe some small pattern like two things helping each other. See, whatever I tried, there should be the ideas that I have tried. If they're becoming too simple, only then we can use them. Otherwise, sometimes if you use such ideas, it will become very simple. Like it will become too obvious to output a pattern. For that reason, I have tried something like this. But then, if that is not helping, maybe each other. Let's say RCB and CSK are actually helping each other. So what do we do? Others, CSK, comma, others. Okay. We alternate RCB, CSK. RCB, CSK. We alternate these things. So now we are trying to group things. We are pairing. So we do RCB, CSK, comma others. CSK, RCB, comma others. If you do all these things, whatever happens, we should just make sure this others doesn't match. Right? So what do? We do just RCB, CSK, RCB, CSK up to so on, and then we can just make others as 1, 2, 3, up to so on, and it might work. So now, except RCB, comma CSK, we'll just cycle everything else. So after n minus 1, we have RCB 1 again. RCB after n minus 2 because other things, right? We'll do it twice. Why? Because once RCB is here and then CSK is here, right? So all the matches. Or should I worry about only RCB being friend rather than two things? RCB being friend, CSK being friend. We have them like this. And then RCB being here will be handled in some other pairing, let's say. All the matches where RCB comes first and CSK comes first, they all can be handled like this. Again one, again two, up to so on. So now we have this small pattern that helps RCB become a CSK all the matches where they are in home ground. Okay. And now we do this for all pairings because we are doing it for all pairings, and this is n minus 2. Probably the 1 and n minus 2 probably will not match to the next things. Okay. 1 2 1 2. So these are other things cycling. Okay. Other things cycling. Wait, I was trying this only right before. Let's just cycle all the teams. Let's just cycle all the teams. Okay. 0 1 2 up to so on n. 0 1 2 up to so on n. Okay, we're cycling all those teams. And then we have 1 2. We can't do these things. It's again coming down, coming to same thing. Let's just say we have only three things. I want to keep other things here. Okay, not let's not keep all. Is it better for three things? This is not that simple or easy question, guys. I don't know how people solve this as this. How this is medium and how the next thing is not medium. So this is still a solution, probably. This is still a solution. Like what? Fix whenever the sum is even, do this. But then whenever these two are equal, maybe skip that, and still maybe it works. Still it works because it's I plus 2, right? I and I plus 2 also will not be equal. Why I and I plus 2 will not be equal? Sometimes this will miss. Okay. Then, but now can this be equal to this? That's possible because this is even. But maybe it won't. It will be equal when this will be missed. Right, it will be equal when this is missed. So what do we do? Some odd or some even. Can we make one has less than half and other has greater than half? No, but then we have to pay equal things also, no? We have to keep n minus 1 pairs such that n minus 1 ordered pairs. N into n minus 1 ordered pairs such that adjacent things are not equal. N minus 1 times n ordered pairs. So this also I have seen here, right? This also I have seen here. What does that say? I and I plus d plus 1. These two will only be equal when d is 0 or, okay, when d is not 0 for sure. Okay, when d is minus 1 or d is 1, only then these two are equal. D equals to 1 or d equals to minus 1. In all other cases, these things are never equal, right? Okay, this is good. When d is 0, okay, these things are a bit better. I don't know why I stopped them again. Okay, we have all these things that's not being equal. Okay, and then they increase gradually. So when this thing doesn't match, maybe we can increase again, and then we can write all of them. So we can write all of these things, but then we are only left with d equals to 1 and d equals to minus 1. Okay, we are only left with d equals to 1 and d equals to minus 1. So 1 comma 2, 2 3, 3 4, up to so on these things, and then 2 1, like 2 1 3 2, these things are missed, or left, right? 2 1 3 2 4 3, up to so on. But now can we shift, can we leave four things, can we leave these four things and then start from here 5 4, and then merge these two things like that? For how will I merge? I will shift, start from here. When merging, it's like keeping them side by side. Okay, keeping them side by side, but then I'll start from here 5 4, and then 6 6 5 7 5 6. If you start like this, probably, and then it's 1 2 5 4, 2 3 6 5, 3 4 7 6, up to so on. So this will probably work, and then we will again come 1 2 cyclic order. So also these things can be placed such that they don't match at all. Okay, okay, even these things can be placed such that they won't match at all. And and now you have these things, right? Now, if to connect this with the whole things, what can you do? You can probably choose to start from here, or from here, or from here, or from here, up to so on, or from here, or from here, or from somewhere else, because we can choose, because we have many starting options, right? There is only one thing here, there is only one x comma y previously. We have x comma y, maybe we can choose from, maybe x comma x plus 1 is there. There is, if there are five things, there is definitely something that is not adjacent to both x or y. Why? X has two things adjacent, let's say, y has two things adjacent, let's say. Maybe if you have six things, you can always choose. Guys, let's sleep, guys. It's Sunday. You guys are discussing CF, right? See, this mine is almost seems to be done, right? It's not that good, but it seems to be done. Why? We have x comma y ending. Let's say we're ending with x comma y. What should we just do? We should just make this not equals to that that. Or here we are starting with something, right? Maybe we can decide what we are starting with. Let's say we are starting with d equals to 1 and it is 1 comma 2. If this is 1 comma 2, maybe place these things before those 1 comma 2 and then you are done. I'm trying for any x comma y to choose here, right? But instead of that, form everything with this other d's. Form everything with this other d's. Okay, 1 comma 2 is your first thing. Place something that's not 1 comma 2 on top and then you have other things done, right? So maybe this works. We need not go till randomization. See, I was just trying to see I comma I plus d things coming first and then d varies. Okay, if you are seeing that difference is d. Now we have to see if these two will match or not. For these two match, d should be minus 1. For these two things to match, d should be 1. So I'm keeping d1 comma d minus 1 aside. With those two things, we can form something if n is greater than or equals to 5. Now I will make all these things, okay? D equals to 1, I make, and then D equals to 2, I make. But then to attach D equals to 1 to D equals to 2, I will change the starting positions if they match because we have many things here. If I go to next, it will probably match, okay? So I comma I plus D is our solution, let's say, okay? We start with 1 comma 1 plus D. So on, so on n comma n plus D. Okay, adjacent things are not equal at all here. So now I'm starting with 1 again, right? 1 comma 1 plus d plus 1 is I'm trying to do. N and 1 are not equal. Okay. We just have to see if these two things are equal. These two things will be equal if d is 1. These two things will be equal if d is 1 because n doesn't matter. We are seeing things remainder n, let's say. These two things will be equal if 0 based index, right? So let me just start from 0 comma 0 plus 1, 0 plus d, n minus 1 comma n minus 1 plus d. So now will be 0 comma 0 plus d plus 1. I'm trying to see if these two things matches, I can shift them, I'm saying, right? But then I'm actually looking at them. Can they be equal? These two are not equal. Can this be equals to this? Only for d equals to d equals to n minus 2 it can happen. And for d equals to minus, when can this be equals to this? For d equals to 1. That I think these two can be equal sometimes. These two can be equal when d equals to minus 2. These two can be equal when it is d equals to 1. But d is anyway not equals to 1. Right? D is not 1. So that can never happen when we are attaching this with this. d minus 2. Even these two will not be equal because d is same, n minus 1 comma 1 are not, never equal. These two can be equal if d is 1, but that also cannot happen. But these two can be equal if d is minus 2. Only then they will be equal. So we can keep coming, keep keeping the same thing. Only when d equals to n minus 2 at the end, this and this may be equal. Right? Only then. Only then. See, n equals n minus 2, this is. Minus 2 means 1 minus 1 were kept aside already. Okay. 1 minus 1 were kept already aside. So now only for d equals to minus 2. Okay. But there is nothing after d equals to minus 2. There is nothing after d equals to minus 2. Right? Why? We go from d equals to 2, 3 up to so on n minus 2. Because there is nothing after d equals to n minus 2, we are good. This pattern works. This pattern just works. Now we have d equals to 1 and d equals to minus 1. We only have to worry about this. Okay. For this we have already kept this. So we start with this. We start with this and then we start from 0 comma 1. From 0 comma 1 we have something nice now. From 0 comma 2, sorry, from 0 comma 2, from 0 comma 2 we have this big pattern, and then we have to keep something that ends with non-zero non-2. That's it, we are done, guys. We are done easily. Do you guys see that? I comma I plus d, it says I, if you're increasing I plus 1 and these are not equal. When can I plus d become equals to I plus 1? When d equals to 1 or d equals to minus 1. So this big pattern is easy. The big pattern is easy and it starts with 0 comma 1. It starts with 0 comma 1. D equals to minus 2 is a problem, but there's nothing comes after d equals to minus 2. We have this thing. So let's first make this pattern. Okay, what is that pattern? 1 2 5 4, right? And then you have 2 3 uh 2 3. What is this? Plus 4, 1 plus 4, which is 5. 2 plus 4, 6, 6. And then what's this? Minus 1, right? 5. So and then you up to so on. What you have here? N minus 1 comma n, and then plus 4. What is plus 4? It is n plus 3. You will have 3 comma 2. Probably we'll end with 3 comma 2. 2 comma 1 came before this probably. So if you're ending with 3 comma 2 and then we are starting with 0 comma 2, that's a bit of problem for us. But let's instead maybe keep this first and then keep this thing. Okay, if you're keeping it like that, what do we have now? 5 4 1 2, and then we will keep 6 5 2 3, and then we will keep This is choice. I'm just taking this one to just merge those two to help each other, because what is d equals to 1, 1, 2, 2, 3, 3, 4, up to so on, we have things increasing. And then what is d minus 1, 2, 1, 3, 2, up to so on, because these are increasing. If you choose from plus 4 and merge them, these two will adjacent things will not be equal, right? So that's this is not like too complicated of a pattern. But now if I reverse them, what will it end with? It will end with 3 to n minus 1 comma n. N minus 1 comma n will not be equal to 0 comma 2, right? For n greater than 5. N minus 1 equals to 2 is n equals to 2. N minus 1 equals to 2 is n equals to 3. So this will not be equals to this. Why do we need 5 things? To be able to start with 5. See? So first we do this pattern. After doing this pattern, we start from b equals to 2 and then we continue this. Done. We are done. For each d we have n things, right? First, what's the pattern? Start from 5, 4, 1, 2, and then you have how many things? N minus 1 things. Okay. Let this be zero based index 4301, and then you have 5412, up to so on, up to so on, 2 1, n minus 2, n minus 1, and then you start with 0 comma 2. So n minus 2 being equals to 2 can happen if n equals to 4, but if n is greater than 4, these also will not be equal. So this is our first pattern. This is our first pattern consisting of n minus 1 things, and then we start from 0 comma 2 and then we are done. So what are we starting with? 4301, right? So we got this easily now. 4301, d equals to 2, d less than, sorry, I'll start with int I equals to 0, I less than n minus 1, I plus plus. Those are n minus 1 things. 2 times n minus 1 things. 0 comma 4, 3, oh, fourth, I have to just insert them into answer, right? Four three 4312. Sorry, zero based index 4301. 4 3. See, implementations are simple. If you come with a good enough solution, my golden rules, LeetCode guys, I don't think you need my golden rules, but I mean, I'm not able to solve LeetCode, so I cannot criticize LeetCode anymore. Sorry for that. Okay, this will end with n minus 2 comma n minus 1, and then we are starting with 0 comma 2, so we are good. N less than, so from 2 to minus 1. So we only have problem with at d equals to minus 2, but then that's not possible. So what should we do now? We start from 0 comma I plus d, right? We just push it I plus d, and then we have clearly verified here that n minus 1 comma n minus 1 plus d cannot be equals to this unless d equals to minus 2. But after d equals to minus 2, we don't have anything, right? So we are good. So this simple pattern works. Why is it wrong though? 4301. So where is our 0 comma 2? 0 comma 2 starts from here. We are not repeating anything. Have covered n is 5. We have covered 2 into n minus 1 things. 0, 1, 1, 2, 2, 3, 3, 4. Covered. 1, 2. Okay. 0, 1, 1, 2. Okay. Few things are missing here. Some are plus but some are minus, right? 1 minute. Wait a minute. 4, 3 is plus, minus. 0, 1 is minus. So everything should be covered here. Everything should be covered. My bad. So 4, 3, 4. And then you have 4, 3. You should have 0, 4, right? 4 comma 5 is this, right? This comma minus 1. 4 comma 3. 5 comma 4. 1 comma 0. 2 comma 1. Everything is there. 5, 4. 4, 3. Where is 3, 2? 5, 4, 4, 3. Wait, why are we missing 3, 2? Everything should come right in this first place. 4, 3. 5, 4. Maybe I have not doing more number of times. I have to do n minus 1 times, and then I'm doing n minus 1 times. How many times should I do? 0, 1, 1, 2, 2, 3, 3, 4. When we have, okay, 4, 5 is not there somehow. Maybe I should do n times. Yeah, I should do n times, because these are n things. I should do n times. But if I do n times, it will end with, if I do n times, it will end with n minus 1 comma n. Even that is fine for us. We should do n times. See, I'm not returning two things. I thought 1, 2, 2, 3 up to n minus 1 things, right? But it's cyclic. It's cyclic. It can be cyclic. That's it. This code will work. But now why is it not working? They're not even telling what's not working. 4, 3, 5, 4, 1, 0, 2, 1, 3, 2. Everything is there, and from here we are starting. Till here we are good. Okay, these two are failing. Okay, now these two will fail. N minus 1, comma 2. We are here. Right, we are here like n minus 1 comma 2. But then that wouldn't work. Why? We have 0 comma 2 here. N minus 1 comma 0. Then we are starting with 0 comma 2. That wouldn't work. 1 comma 2 also wouldn't work. So we cannot just flip these two. What about starting from, what about 5 comma 4? What about 4 comma 3? 4 comma 3 seems fine, right? So let's start from here. Then what happens? We will have 4, 3, 0, 1. This is what happens if I start from here. So instead of this, Let's start from here. Let's start from here. Then 4301 happens, but also print this first and then this next. Okay. So we are going to flip these things, and then we are going to add one to everywhere, so that before 0 comma 2 we get 4 comma 3. See, before 0 comma 2 we got 4 comma 3. See, it's all simple. What happened wrong was I thought there are n minus 1 things, and then I made sure everything to be correct, but then there are n things. Now I have to just make sure everything to be correct. So it's not too difficult, right? I struggle, but yeah. See, just this one works. We need clarity. So, guys, this is a good problem. This is a good problem. We see, we cannot output some weird thing, right? See, Diogana Dugyani, but Pradeep KR, you have to keep golden rules in mind. If something is not that easy to prove, you will struggle. You don't know how to do it, right? Your implementation cannot be simple. Did I start coding? Did I start coding before I made my implementation very clear? Check. No, right? And even after that, and even after that, see, just I comma I plus d is working. I thought more by odd comma even unnecessarily. This is even simpler pattern. I comma I plus d is even simpler pattern. See, you have to be very clear that you have to be very clear that finally what do you code and output. You cannot magically use some code, weird code that outputs these pairs that will not match adjacent things, right? You cannot magically do that. You must do something sequential. You must do something sequential. Maybe I will go sequential with respect to I comma I plus d such that I and I plus 1 will definitely not match if we increase plus 1. So now, so this is a best simpler thing one can think of. I did that with O comma E, and then I'm increasing there. Here also the difference was fixed, but then they need not be odd and even. They need not be odd and even. I thought to make them odd and even because I thought I need not worry of this and this. But then if you try to worry about this and this, it's just d equals to minus 1 and d equals to 2. Just those things, okay? Because of that, I started with this. But then here, even comma even is left out. And then I don't have a solution for even comma even, right? With that theory. I haven't paid much attention there. So, but here, only problem is this matching with this or not. See, you guys have to realize that I came up with a final solution by trying to check very carefully. Okay, what about this thing? What about this thing? I I comma d plus 1. What about this thing? Whenever d not equals to 1 or minus 1, all these things are good. And then I was trying to check, is this will this just work? If I when I was checking, will this work with the next thing? You guys would not have written all these things, right? And then you guys will think, I'm only able to solve first question. What should I do? The fuck, you never tried third question. You never tried third question with some clarity. You never tried third question with some hope that it's difficult than fourth one. That, okay, if I am finally outputting some simple code, what could that code be? Maybe I comma I plus d will help me to not match these two things already. When would this match with this? When I d equals to 1. When would this match with this? When d equals to minus 1. You're seeing everything with reminder modulo n. So minus 1 has some sense. Okay. Now keep those minus 1 comma 1 aside. Everything else you can keep in a line. So only things that are left are d equals to 1, d equals to minus 1. Okay. Everything else you can keep in a line. and adjacent things will not match. So there you have so much of pattern. Okay, should not try to think randomly. You guys have to see, because whatever you code finally is simple. You have to believe that. You have to believe that, and then you have to try for such ways. See, my idea is not differing. Why I didn't want it to worry of these two things. That's why I wrote odd comma even. But then this cannot be applied for even comma even, right? Even comma even pairs exist. I thought everything can be written as o comma e and then e comma o and then we are done. I thought that, but that's being careless. I thought o comma e comma one is enough for everything, I thought, but then that's not true. So I came to just check this thing. Do you guys see? Like that's all I have tried so far. This was some cyclic thing that's not working, and then d equals to 1, d equals to minus 1. Those are the problem causing things, so I separated. And then I clearly checked. When will when will where is that? I clearly checked when will this will be equals to this. It's always ending with n minus 1, so that we are good. So these two are not equal. When can this be equals to this? When d equals to minus 2, because this is minus 1, right? So d equals to minus 2 is one bad thing. Okay, now check this one with this. D equals to 1, this both can match, but then d equals to 1 is not already a case at all. And d equals to, when will this match with this? Never. N minus 1 and 1 never matches, right? And now d equals to minus 2 is the only problem, but then d equals to minus 2 is the last thing, right? If you remove 1 comma minus 1, n minus 2 or minus 2 are same thing. So I need not worry of that too. So all these things are already not matching. This pattern is already very good. Just this pattern of 0 comma 1, 1 comma 2, up to so on n minus 1 comma 0. And then just this simple pattern is already very good. But you have to start from minus 2 and end at plus 2 and then end at minus 2. So now what about 1 comma minus 1? D equals to 0 is already not there. Those things somehow you can arrange and then you can just keep them in front of 0 comma 2. Not that difficult. Okay. So do you guys see? Can I not solve this problem? You're not trying hard enough. You're not trying as hard as high. And then you think how to solve the problem, right? Did I leave this problem thinking I may not be able to solve in live stream? I kept trying, right? You guys don't try. You don't need topics for this problem, right? It's a good problem because you don't need topics. And then see, you know that you do something sequential. That's why the simplest pattern is working. I tried for something else, but then the simplest pattern is working. You have to prove also, right? D equals to done. So I'm ending this. I think I explained it well. I like to assume that I have done. See, try. You're not believing golden rules. When I say my golden rules are, see, try. When I say golden rules, you have to believe them. Solutions are simple, proofs are simple, implementations are simple. Okay. See, guys, we have golden rules. If you see my profile, we have golden rules. They are always true. They're always true with respect to a problem. Okay. You can't ignore all of my golden rules, and then go and try randomly something. Okay. Because I believe that whatever the code you write, you must not match those things. That's why I was able to keep d equals to 1, d equals to minus 1 aside. Okay. Why I was able to keep d equals to 1, d equals to minus 1 aside? I believe that there will be a simple proof. I believe that there is a simple proof. Okay. Do you see? I say golden rules, but then you think my golden rules are just some positive bullshit, right? They're not positive bullshit. They can be used to solve the problems. Okay. I am using them to solve the problem. That's why I was being clear. I was being clear with d equals to minus 2. Do you see? I was even clear with, where is that thing? I was clear with d equals to minus 2 even before coding. Do you see that? And I was clear with these things too, but then what happened was it's cyclic array, right? So we have n things. I thought we have n minus 1 things, but then we have n things. Because of that, the last element got changed to n minus 1 comma 0. Here itself I tried shifting this, swapping these two, but then without swapping them itself it was done. These things are cyclic. These things are cyclic. So I can start with 5 comma 4 itself. See, we have some cyclic patterns. This starting from 0 itself works for everything. And then d equals to 1, d equals to minus 1 doesn't work because I believed in there is a simple proof. Okay. Random things, if you can't prove easily, you should not go in that direction at all. There will be one guy who might have tried brute force, right? Okay, try itself has tried brute force, right? Yeah. See, doing proofs is not an additional thing. Doing, when I say proofs are simply how to use it to your advantage. Okay, the way I tried, the way I tried initially was also odd even, but then I have to realize that odd even will not. Odd even is also the same thing. I'm trying to see difference being fixed. Difference being fixed is same as this thing. Okay, but then I didn't want to worry about this one and this one. For that reason, I kept odd comma even. But then this one and this one will become equal only if d equals to 1 comma d equals to minus 1. It's not that complex. When will I comma, okay, my pattern is I comma I plus d, and then next one will be I plus 1 comma I plus d plus 1. These are cyclic, so it works everywhere. And now when will this one be equals to this? Only when d minus 1. When will this one will be equals to this? Only when d equals to 1. So I wanted to trespass this. That's why I kept 0 comma o comma e. But then e comma e is anyway missed out. I cannot use the same logic. So I just came to I comma I plus d. So now if I be a bit more careful, d equals to 1, d equals to minus 1 is the only case where this fails. So just keep them aside and then see if you can match this and this. You cannot match them only if d equals to minus 2. It needs work. It needs some belief that proofs are simple, and then it just needs work. See, even lead code questions are good questions. Like this is a good question, right? This all questions, all coding questions follow my golden rules, because golden rules comes from the fact that you're finally going to submit a code. Codes cannot be too complex. You cannot do random things at code, right? Maybe sometimes you can do by maintaining sets, but then if that code is being correct, if that code is being correct, that means it can be broken into some simple things that are correct, right? If the code is correct, that means okay, you're doing something correct. It can be proven that your code is correct, right? Otherwise it may not work. Otherwise there is a test case that fails your code. That means there must be a simple proof that says your code is correct. So if you assume solutions are simple, proofs are simple, implementations are simple, you can remove these kind of solutions. See, someone has told me, Jay has told me long back to maintain sets, but then why didn't I do that? It's not that easy to prove that. Teams in one set, picking the teams whose last match was before else, and then it's not that easy. Okay, implementation also may not be easy, and then I cannot be sure if it's right or wrong. But then I was not. That's why I didn't prefer that, because I know proof should be simple, solutions should be simple, or like that. But then this worked. Constraints can be low for any reason. Some DP solution, it's not being that easy here, right? What is a DP solution? You have to get a whole pattern. Why didn't I try for a DP solution? I tried for a DP solution. See, when I told induction, can I see if induction works? Induction is DP, right? You may not agree, but induction is DP, right? I tried looking at induction. It didn't look so simple to me. Induction didn't look so simple to me. When I'm adding a new team, we have to know previous team's positions. So induction was not simple. Hence DP also won't work. DP or induction are the same things, right? Almost same things. See, induction plus bijection among sets is DP. You go forward. See, solving n minus 1 before solving n is not DP. Yeah, it's easy to say. Like we have to think. We have to think. Yeah, induction. I meant induction and bijection, but fine. Induction, in basic induction, right? Okay, guys, it's 1:28. Let's just sleep. So See, you guys should have clarity. Okay, from every problem, you guys should try to have clarity in how you're doing. Okay, yeah. So I have solved all problems. Done. I have to sleep. Tomorrow I have some work to do. Not work, I have to meet. Not meet, I have to go out. No, not even out. I will get someone in. So I should not say all these things, I guess. Bye. I have to sleep now. Yeah, we'll do lead code contest, but then it's not about lead code or code forces, right? You guys should believe in golden rules. You guys should try more. See, uh, Dugyani Sasi Kumar, you when I told you guys golden rules long back, but then you guys were not giving importance to that because lead code questions are also not. This is not like this is a constructive question, right? This is not like a. I mean, I complexed it, but then this is a bit simpler only than it is. But in contest pressure, like you have to simple proof pattern is the only thing that is giving me a simple proof, not great ideas, checking carefully, checking everything. D equals to minus 2, I thought, is it breaking? D minus 2 is the only one thing, right? It doesn't break everywhere. So where is D minus 2? Myself. Happy journey. Bye-bye. See, guys, you guys should share my thing to others because no one will give you such good explanations for this problem, right? People cannot live stream on live because it may damage reputation if I cannot solve this, right? And my explanation to D is also top notch. Someone at work was questioning if I am writing top notch code or not when their code base is entire. I cannot say wrong things. That's why I'm flexing my coding skills here. My codes are top notch, right? See how clean they look. See how clean they look. Simple code. See how clean it looks. Simple code. This doesn't look that clean because the question is not clean. One thing I learned at work is such weird naming things. Otherwise, I would have just kept it F, I guess. So, because this is premium content, right? Someone else, if they do post contest discussion, they start with the pattern and then they say it works. They wouldn't give you the explanation that golden rules comes from the fact that you finally submit a simple code and the fact that it should pass all test cases. The fact that it should pass all test cases gives you proofs are simple. The fact that you submit a simple code gives you solutions are simple. Also implementations are simple comes from the fact of both things easily. Yeah. So I have broken down this weird constructive guessing kind of problem into something that is tryable. You have to try for patterns that you can easily prove. Patterns that can easily prove are I comma I plus d is easily proved because I and I plus 1 doesn't match already. Now we have to think about I plus 1 comma I. Maybe that's also not matching. That's also only matching when d equals to 1 minus 1. Keep them aside. You have most of the things not matching. Now minus 1 comma 1. When I took odd even the same idea almost. I don't want to care about even matching with odd. So, but then only it happens only for D1, D minus 1. So I should have backed down here itself a bit, and then I tried I comma n minus I, and then this seems itself working. See, when it doesn't work, we have to logically see. You cannot write things down. You cannot write 1 comma 2, 2 comma 3, 3 comma 4. Instead, I wrote them simpler, right? I wrote them in terms of I comma I plus j. Why did I wrote them in general format? Because I want to prove things, right? I don't want to guess something and then see if it works. I want to prove things. That's why I wrote it like that. Because I'm proving things, d minus 1, d1 has been separated out. But then if you're guessing things, you cannot start from d equals to 2, right? Randomly. Right. Focus on proofs. Okay. Even LeetCode is demanding proofs. So my first contest went well. I'm ending the stream. I'll give tomorrow contest, and then I will immediately post it. See, guys, if how you solve this shit, no DSA sheet can help you. Okay. If how you solve, we both can take same problem, and I will do it in a better way. I will learn more from a problem than you will ever do. Okay, which DSA sheet is the best? See, problems are not like reversal linked list now. Okay, problems are constructive. Problems are not that easy. Problems need work. It's not knowledge anymore. Okay, with AI coming, it will problems will be more difficult too. If you want to get jobs, I cannot say these things, I'm just joking. I'm telling it's about how you solve. Okay, Guns and Roses. Which DSA sheet best? What is best? You want to try out the best sheet? Try to use what you already have. Okay. Guys, why are you laughing? I don't mean anything against you, Guns and Roses, but then I don't get you mean like, is it like, do you think like if you find some golden sheet, if you find some sheet and learn the patterns from there, you can solve any problem, and others, people like me who hasn't found your sheet, cannot solve a problem that you can solve? Do you think, is that the way? Do you think there are like, are you really believing the LinkedIn post that says DSA was tough before I saw these 40 patterns? Are you believing that? And let's say you found that sheet and then I didn't find that sheet. Okay. Let's say you found the best DSA sheet and I don't have the best DSA sheet. If you both give a contest, will I do better than you? Probably, right? So guys, the complete process is one thing I can say is we have to believe golden rules a lot. They seem simple, but then they are very powerful. I guess they are very powerful because proofs are simple. First itself tells you have to prove things. You have to prove things. You have to get better proofs. Okay. See, they have more engagement than me. So what you guys should do is you guys should learn well from me, and then you guys should say that my things are better. Okay. First you have to learn. If you guys are not able to learn, it's useless whatever I do, right? So you guys should try to see the fact that if you improve your proving skills, you can perform better. If you see maybe one problem, maybe within 2 months, 3 months, you solve one problem where you were able to solve it better because you are trying to see the proof, where you were able to solve it because you're not guessing, and you are see, listen to me, you guys should try at least maybe one problem you solve, and then you do it because you're trying to think of the proof, you're trying to think of the correctness of your code. Because of that you have solved the problem. See, Guns and Roses, what I mean is, it's how you solve, it's how you reflect after solving a problem, how you try to follow just few rules to solve more problems, how you try to prove things. Because when some question passes everything, you have to think, why is it passing everything? Can I prove that it passes any test case? You should not just go, okay, my random process is working now, right? So you must prove things always. So it's not about DSA sheet. Okay, if you prove, if you maintain some things as you go by, you improve, and then you do well, 27% of the people has solved greater than 5 questions. Did they keep it like a joke? You have to prove things clearly. Most of the times it will be simple once you prove it. Okay. Once you guess the solution, it's simple. I'm ending the stream. Good night. Share to friends. If I do lead code, there will be more audience for lead code. You guys should share my streams to lead code. Bro, don't you know how to prove things? Go and study a bit of math, okay? Prove that n into n plus 1 by 2 equals to 1 plus n up to so on n. Take some things, prove those things. Google how to prove things. Google like some math problems I can prove. Or join my group. I gave some book, mathematical circles to prove, okay?